Saxon Algebra 2, Lesson 77. Advanced radical equations. Man, we're just getting too smart for our own good. We've seen radical equations before. There are a few extra bells and whistles. I'll explain as we go. Hi, Grace. She just came in to join us. Gracie's my dog, if you don't know that. 77. I'm on the wrong lesson. Oh, that's not a good sign, is it? Okay. It looks like this. It tells us to solve. Whew, that looks like a lot, doesn't it? We've got this big old radical. There's something going on in here that I can't quite make sense of yet. I don't know what to do with this, but that's not my problem. The very first thing that we want to do, I'm going to write our steps over here. Isolate the radical. That is our first priority. And we remember, we just look for the biggest, ugliest mess inside the pig house. Oh, this is it. We want that by itself on one side. Okay, so this is easy. We just add to get rid of those, and we will get cube root of this whole weird thing. Notice it's a cube. That doesn't change our steps. It just makes life a little crazier. Okay, so that cancels and that cancels, and then we have x plus 2 over here. All right, so now we've got this thing by itself. Now our job is to, we used to square it, but this is a cube root, so we have to cube it. So what I'm gonna say, instead of saying square both sides, I'm gonna say reverse the root. That's our second step. And that means undo whatever this is. So in our case, we know we're gonna have to cube it. And so we have to cube that. Yikes. Okay, we'll do that. This side now becomes a dream. X cubed plus 6x squared minus 4. This, we don't even know. Now I can square it in my head. I know that the middle term, I'll be adding these two numbers together. And the last term, I'll be multiplying them. So I think it's gonna be x squared plus 4x plus 4. But let's just go ahead and multiply the whole thing just to make sure that we're on the right path. X squared plus 2x plus 2x plus 4. There it is, just like I thought. X squared plus 4x plus 4. So if you can multiply binomials in your head, go ahead and do it. But now we're cubing it, so there's 1 times, 2 times, we have to multiply one more time times x plus 2. I'm running out of space quickly, aren't I? All right, I'm gonna have to squish. I'll move it up a little so you can see better. X cubed plus 4x squared plus 4x. Thank you, she sits down, her turn to dance. We'll line them up properly. 2x squared plus 8x plus 4. Okay, everything's multiplied. I just have to add these. Since I'm so squished down here, I'm going to add them and write my answer right up here where it belongs. So it's going to be x cubed plus 6x squared plus 12x plus 4. A little squishy, but I think you can see that. Come back down a bit. Okay, now we're ready to combine like terms. And I'm not going to write that as a step because once we get to this place, this should look and feel pretty good. Now, look what happens. I'll go, okay, let's subtract the x cubed. It's going to drop out because I'm subtracting it from both sides. And look at this. When I subtract the 6x squareds, it drops out of both sides, which means that all I'm gonna have left, I'm gonna take care of that much. Look, all this cancels. I'll get minus 4 equals 12x plus 4. Ooh. Oh, wait a minute. This should be an 8. Have you been dying? Since I didn't see that, right? 2 times 4. This should be an 8. So when I added them, this should be an 8. And now this should be an 8. Okay, better, right? 2 times 4 is definitely 8. Okay, so that was just a multiplication mistake, and I fixed it as I carried it through. All right, I'm gonna move my plain numbers to this side. And I get minus 12 equals 12x. Are you kidding me right now? And we get x equals minus 1. Okay, now, whenever we reverse a root, so to speak, as we do here, whenever we get rid of a pig house by blowing it up with an exponent, we have to check our roots because we can often get spurious roots. So that's my third special tip for you. Spurious roots just mean numbers that masquerade as answers but really don't work. So we have to check our answers. So what we have to do is go all the way back to the beginning and check to see if minus 1 works in this. I'm gonna do that on the next page because I'm running quickly out of space here. So I'm gonna copy this to the top. And that is like this. I'm gonna have to rewrite the whole thing. You don't have to if you can see this on your original, at the top of your original problem. You don't have to rewrite it, but I do. Okay, and then we're checking for x equals minus 1. So here we go, buckets away. We've got negatives in our value as well as our formula. Definitely want buckets. That's third, plus 6 times minus 1 squared, minus 4. That's all in the pig house. Minus 1, minus 2. Okay, let me just look at that for a second and make sure I didn't make any ridiculous mistakes. Okay, that looks good. So now let's start simplifying. Minus 1 cubed is going to be minus 1. Minus 1 squared is positive 1 times 6 is 6. Okay, so this then equals minus 1 and minus 4 make minus 5. 6 minus 5 equals 1. So this whole thing nets down to being the cube root of 1 plus 1 minus 2 should equal 0. The cube root of 1 is 1. So 1 plus 1 minus 2 equals 0. Hey, it's true, isn't it? Right, because this is 2 minus 2 equals 0. So that's true, smiley face. So we can go back, this is check. So now we can go back and officially box our answer. Let me see if we get one. Yeah, later we'll get a problem where it doesn't, the answer doesn't check out, and we'll see what you do about that, okay? Once you prove, though, that your answer does work, you can go back and just make it official. Okay, let's try another one. Again, John tells us to solve. This is letter K. Just to be fast, I make it kind of like a cursive K. You could do yours however you want. Now, look at what's going on here. We have 2 radicals. What the actual heck? How can we isolate the radical if there's 2 radicals? All right, let me let me fine-tune my instruction to you. Isolate the ugliest radical. And I know this is judgment and shaming involved, but I think this is uglier than that. So this is the one I'm going to isolate. So I'm going to add square root of k, and I'm going to subtract a 1. And then I'll do that from both sides, right? Square root of k minus 1. So then I'll have square root of k minus 5. This ugly bad boy, he'll be by himself. We cancel these out, and it equals square root of k minus 1. Okay, our next step is to reverse the root. This is just a square. There's no number written there, so that makes our life a little easier. But now we're going to have to square both sides. What the heck just happened there? Well, we'll figure that out. As soon as I do this, I remember, oh, spurious roots are us. Because we're powering this thing up, we're going to have to be careful about that later. This side is beautiful now. It's just k minus 5. And now I have to multiply this just twice. Last time we had to do it 3 times. But I'm going to multiply this one out. I'm not going to trust myself to do it in my head. Square root of k times square root of k equals k. I like that. Minus square root of k. She's done. Her turn. Minus square root of k plus 1. So our final answer would be k minus 2 square root of k. That one just went in a different way. Plus 1. So this becomes my right-hand side. I always think it's weird because it goes from being most disgusting on the left to most disgusting on the right. Okay, so far so good. I like it. Now, let's see. What can we do to combine these like terms? I would like to subtract a k from both sides. Ooh, that looks good. And then let's bring this 1 over to this side. Then we'll have the radical over here. So let's subtract 1 from both sides. These cancel. These go to minus 6 equals minus 2 times the square root of k. All right. Well, let's get rid of this number here by dividing it away. That's easy. That's 3 equals the square root of k. And then once again, possibly creating more spurious roots, we square both sides, right, to get rid of this pig house. And we get k equals 9. Such an innocent number, right? I wonder if it's true. Before I box it to show it as my answer, I'm going to check it because it might be a spurious root. So what I'm going to do is I'm going to take the 9 and I'm going to plug it back into our original equation. I think I've got room to do it here. Check. Square root of 9 minus 5 minus the square root of 9 plus 1 equals 0. I am not using buckets this time. I'm living dangerously, but that's because my value isn't negative, and these minus signs are pretty clear in my head how they work. So I'm going to go ahead and try it without buckets this time. This becomes the square root of 4. Square root of 4 is 2 minus square root of 9 is 3 plus 1 equals 0. Is that true? There's a positive 3. There's a minus 3. So it's 3 minus 3 equals 0. That is true. So this answer checks out, and now I can box it up and give it a smiley face because it's the right answer. Okay? Check the work every time for those spurious little roots. Okay, we have just one more. Yeah, there are 3 in all. It's my favorite number of examples. Ready? Example 77.3. Solve. Whenever we see the word solve, we know that means, oh yeah, we'll get an actual answer, x equals. Okay, we've got multiple radicals again. You know what that means. We have to figure out which one's uglier and subtract it away. Isolate the ugliest radical, right? So this one's cuter, he's going away. So we get square root of quantity x minus 8 equals, now I'm going to put the 2 first and then the minus square root of x. It's hard to decide what order makes more sense when you have a square root and a 2. It doesn't really matter. It'll work either way. I like to keep the minus sign between them because it's easier for me to keep track of the minus sign if it's in between the two other terms. It just works better for me. Squaring both sides, this becomes just a plain old x minus 8. Here we're going to have to multiply the binomials. 2 minus square root of x times 2 minus square root of x. This is the biggest pain in doing these problems, is that you have to multiply out these crazy binomials. 4 minus 2 square root of x minus 2 more square root of x plus x. Okay, so we add this together, and that will go on the right side. Okay, I look to my highest terms first. The plain x is the highest term. I'm going to subtract it, and look, it's going to go completely away. Ooh, I like it. These minus signs are causing me some drama, but I'm going to leave them as they are. I'm going to swim this 4 over to this plain number side. So let's see what I did. This cancels, this cancels, this cancels. This is an addition, negative addition, equals, and then this is all I have left over here. Okay. All right, divide both sides by minus 4. This becomes 3 equals, that goes away. Oh, this is the same answer that we got for the last problem, right? 3 equals the square root of x, so then we square it up again to get rid of that pig house, and we get x equals 9. But we better check it. Okay, it's a lot easier to check when my solution and my number are on the same page, aren't they? All right, let's see what I've got here. 9 minus 8 plus the square root of 9, because 9 is x, equals 2. Okay, 9 minus 8 is 1. Square root of 1 is 1. Plus square root of 9, that's 3, equals 2. Uh-oh. 4 equals 2. That doesn't sound right, does it? That's false. Or, as I often like to note, dead smiley face. So, what we do for our answer is go like this. I show the x minus 9, but I cross it out. And I write the null set, the empty set, those are 2 brackets that are empty, or we can write no solution. We can write those words out. It's very important that you show the solution that you thought, that you calculated, but cross it out to show, no, it didn't work. And then use one or all of these notations to show that there's no answer to this problem. It didn't work out. This one's called the null set. 0 sometimes is called null. This is called the empty set because we use these little pointy things that we use to designate sets, and there's nothing written in there. So it's the empty set. Or we can just write no solution. When you get to college level math, it's important that you know if your professor prefers one or the other of these three different ways of showing it. This is exactly how I want to see it. I want to see your solution crossed off, and then I would like to see all three of these because I want to know that you are familiar with all three of them, so that if you get a teacher that prefers one over the other, that won't flutter you. Part of my job is to prepare you for other teachers and to show you the different details that they might focus in on so that you're ready for anything. That's my job, is to make you ready for anything. That's not hard at all, is it? Okay, guess what? That is the end of lesson 77, Advanced Radical Equations. I hope you feel smart, because once again, look at what we're doing. This is crazy. Right? Look at that. This is good stuff. You're smart. Be proud of yourself. Thank you. Bye.